Hey everyone, and welcome to the next session. And the title for the talk for this session is A Case for Microinteraction and Animations in Mobile Apps with React Native. So let's get started. My name is Akshat Paul. I'm an author and a developer. I've been in this field of software development for almost 12 years, working on all kind of application, web apps, mobile apps, DevOps sometimes. I also have a fancy pen designation at my place of work, which is digital expert at McKinsey and Company. To connect with me, you can always follow me or just DM me. My DMs are always open on Twitter at Paul Akshat. And the best way to connect with me if you want to discuss any new application you want to build, or you're just stuck on React or React Native and few other technologies I have worked on, is the best way to contact me is through www.akshatpaul.com. That is where you can easily find me. And what are my upcoming plans? What's my next talk, or what I'm writing? You can find all the details there. So do visit and do connect with me. So a few of the books that I've been part of over the years, the most recent one, React Native for mobile development, in order to build stunning mobile applications using React Native, and few of the book as a technical reviewer on various topics that I have worked on over the years as a software developer. So let's get started with today's agenda. So our agenda is divided in four parts. Micro interactions. First, we'll know what are micro interactions, how micro interactions and animations are connected with each other. How can we build micro interactions with React Native? Essentially, in mobile apps, how can we include micro interactions? And that will be through a demo, because I believe no technical talk can be completed without a demo. So I'll show you a quick application how you can build it, and my target is that by end of this talk you should be able to build small micro interactions in maybe a not so intuitive application, if you have built any, and include them and build a better connection with your users, and you'll see how important they are. Many of you might be actually using them already, but you'll get to know the structure and the funda behind micro interactions. Lastly, what are the popular libraries, especially related to React Native, which you can use in your applications to make things easier and implement these animation and micro interactions in a much faster way. So let's get started with part one of our talk, which is what are micro interactions. Before we get into the official definition of micro interactions, let's look at a quote which is one of my favorite quote on this topic of micro interactions, by Victor Papanek, who is a Austrian born American designer and educator, a very prominent person in the world of design, who has a book called Design for the Real World. You can check it out, and it's not just limited to software, but actually design principles in general. So it says nothing big works, and that's exactly in long story short definition of micro interaction. But we do have a longer way to describe what are micro interactions. Micro interactions are small moments where the user and the design interact. When they are well designed, micro interactions enhance the user experience with the design, and when they are poorly designed, they totally damage the experience. And we all are, I think I mentioned it once before, that we are surrounded by micro interactions all the time, and we'll get to see in both real world and in the software world, in our virtual world, and we'll get to see examples how when implemented correctly they are a delight to the customer, to the end user, and if they are terribly implemented, they really become a problem to use our product or our service, or our software. So let's look at two examples of micro interactions in real world. So as you can see on this slide, we have two examples. One is a toaster and another one is an egg timer. The toaster here, the micro interaction here is that once the toast are toasted, once a bread is toasted, they pop up and sends a signal, which is a kind of a trigger to the user that the toasts are ready. The second one is an egg timer that it pings to let you know that your eggs are cooked to perfection. Uh, though these are very simple tasks and we think that they come by default, but these are those small micro interaction, and they actually have a proper steps to be followed in order to make them successful. So let's look at these four steps of micro interaction. First being trigger, second rules, next is feedback, and then loops and modes. Let's understand them one by one. The first one is a trigger. A trigger, or the first step, is when we initiate the micro interaction. For example, if we take an example of washing a hand while interacting with a sensor tap, which automatically pours water. In that case, when you want to wash your hand, then you'll wave your hand in front of the sensor. That will be called as a trigger point. It starts our interaction. The second step are the rules, like what has to happen when something gets triggered. Example, when we put our hand in front of the sensor recognizes that there is a hand or there is a movement or something like that. The third step is feedback, which is the verification of a micro interaction. Once the verification is accepted by the sensor and passed to respective controller, the tap starts running, and then we can wash our hands. The final step is the loops or modes, which determines whether the micro interaction has to continue or it has to stop. Example, if we look at our example going back to our example of a toaster, we would not expect a toaster once the bread is toasted, it should keep popping, because it would spoil the warmness or the freshness of the toast. While a common micro interaction in refrigerators is that if it's open, the refrigerator door is open for too long, it starts to beep, and it will continue to beep till the time user intervenes and closes the door. So the final part, which is loops or modes, where loops is continuation of the rule, and mode is that it stops, just giving a signal, just providing the information to the end user, and it stops. However, micro interactions are not just limited to system. They are also user generated, and at some time they are system generated. So let's look at the methodology of micro interactions. So let's look at the methodology behind a micro interactions. A micro interaction can be triggered either by a user or by a system. By a user, I mean via a button or performing some gesture or some voice command. Micro interaction are also triggered by system when the system meets certain criteria, certain predetermined conditions. After the micro interaction has been triggered, it provides some sort of a feedback to the user. This means that micro interactions can be local, and as the name implies, they are pretty small in terms of the larger user interface. But despite being small, micro interactions are very important because they smoothen the user's path through the design, making each step easier in order to use whether your device or your software or your application. Let's now look at how we achieve it in the world of software with animations. So now we come to the next part of our talk, which is animation. So animations and micro interactions are quite closely related to each other, and it is one of the most common ways to implement micro interaction for any application, web application, mobile application. We'll see a lot of examples related to mobile apps. However, animation is not micro interactions are not just limited to animations. Even sound and a vibration of the phone when you receive a message is also a kind of micro interaction. However, animation is still part of it. Like if you get a message, you get a phone vibration and a ding sound, yet there is some kind of a animation which appears, a pop-up of the notification or something like that. But animation is a very integral part, especially in mobile apps, in order to implement micro interactions. And these are very small interactions, but are a delight to the user, and somebody has programmed it. So as developers, we have to program these tits and bits here and there in order to improve the experience of our end users. So let's look at few of the examples. Very often in various mobile apps we interact with every day. Though there are quite a lot of such interactions and animation, especially in mobile apps, but I won't go through all of them, just few very, very commonly used. The first one you see here is pull to refresh for reloading a page. It's a very common interaction we see in most of the smart devices, especially iOS based applications, where we pull our page in order to refresh it, and in order to know that the refresh is happening or it is success, we see that rubber band effect. And once we 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 leave it, it goes back up and a loading spinner comes in. So this whole interaction helps us understand that something is happening while the page gets reloaded. It's not just a simple update on the address bar, especially in this case of Safari, where even the loading bar is getting updated. The main interaction here is when we pull, we relieve it. The rubber band effect comes, and there is that loading icon. Let's look at the next one. Here is a very popular animation or a micro interaction of Siri or even Google Assistant in case of Android phone. Both works in pretty much the same way, and the way it interacts with user is that user say, "Hey Siri," and you see this animation of Siri which pops up on your screen. And which means that it's hearing you, and when you start speaking again, there are these waves form which comes on this ball, which further says that it is listening to our instructions, and then of course at the end there is the final animation where it starts working its magic, that it's computing something or it's processing something. So all these steps, these three steps, when we say "Hey Siri," and the Siri ball appears, and then there are those waves that it's listening to you and then processing. These are those three small independent micro interactions, but collectively they help the user to stay with the application, stay with the service till the time its instruction gets concluded. Let's look at another example. So one of the most common feature for any application is loading. While loading a specific feature or the whole page, or a specific component, and it is painful. But it is a kind of a necessary evil. However, micro interaction can make it more engaging process for the user. Like we see here, we click on a button and there is some request which happens in the background with our server. And of course, meanwhile, the user sees some kind of animations and passes their time. So since most of the loading part is related to some kind of a activity or a function which is getting executed, specifically if you are making multiple requests, and the loading time, if it is slightly longer, a micro interaction is a great opportunity to entertain our user in the meantime, so that they do not lose interest in our application while they're working on it, and continues moves on to the next step. Similar to loading, downloading is another action which takes considerable amount of time at times, and thanks to the world of instant gratification and short videos, the attention span of the user and patience is quite low. So micro interaction again is a great opportunity to hold the attention of our user with some kind of an animation that something is happening for them, even a messaging, while something is getting downloaded and keeps entertaining the user. But especially in case of mobile apps, we always we can split it into multiple animations so that we can catch the attention of our user while the file, the program gets while the downloading gets completed. Let's look at one more example. So here we have an example of hovering, and especially in social media like Facebook, where if you want to put a reaction on any post, there are multiple options, and they all are animated icons. The reason being. Is that you're not just scrolling through Facebook newsfeed and by mistake you liked something. You don't even know what you liked. You're not going to go to your some activity log to check what all things you liked or did not like. With this micro interaction, what Facebook is doing is that you are actually looking at the animated icons, what they mean. They also have a meaning just above that, whether angry or whether you're laughing or whether you love it or whether you like it, and then you select it so that it's a conscious decision which the user is taking. And it adds value of liking or ignoring or being angry on some specific post. Of course, there are a lot more such animations, such as switching and toggling, swiping up in application, notifications. One of the most common type of micro interaction, and pretty much in all social media applications we have notifications. Then there is call to action. So there are a lot of such small micro interactions which grabs the attention of the user, and some and many a times its purpose is that the user sticks to the application, or if there is some kind of a longer process or a painful process, it makes easier for the user by breaking into various steps, showing them an animation, and they proceed to the next to the journey of the application. Let's look at the third part of our presentation, which is micro interaction in mobile with React Native. So, since I'm sure most of you know what is React Native, since we are sitting in React.js case study festival, but still, if any of you have no idea what React Native is, React Native is an open source mobile application framework. It is used to develop applications primarily for Android and iOS based devices. Of course, there is support for Windows and other form factors too, like tvOS, etc. By helping developers to use React framework along with native platform capabilities. I don't have to say a lot about React Native. It's pretty much uh, a popular and a go-to application framework to build mobile apps, especially for React developers. If you know React, it's quite easy to build applications in React Native, and its community support, the amount of libraries which are now available is just tremendous. And in last few years, it has really become very stable, and developing the developer experience on React Native, the whole ecosystem, using various tools like Expo, etc. It really makes development fast and fun, and the time to market and the quality of app is really high. So let's get started with our demo. And I'll create a very simple micro interaction using React Native and Expo. So let's get started. Let me open the code. Also, let me start this application. I've created a basic skeleton of this application. It's like a standard login page which I have created, whereby we'll on a login page, a kind of micro interaction which we can create, and we'll create it together in this demo. So let me open the basic application on the simulator. Cool. So imagine if Geekle has its conference application and this is the login page. Of course, nothing works here. So what should happen when we click on sign in? It can be a simple sign in and the form appears. But we can put in some animation and make the sign in username, password appear, disappear, something like that. So I've created this a simple React Native project with this background of a Geekle logo and a sign in button and a fake sign in with Facebook button. So if I click on it, basically nothing happens. So now in this example, let's add a username and a password here somewhere, and of course a sign in button, and it appears from appears from the background. It feels like it is appearing from the background, as this as this background image move upward. So let's start building that. So for this demo, I'm using React Native gesture handle and React Native reanimated, two popular libraries used for animations and gestures with React Native. So let's get back to our code, and we'll be placing another animated view here, and with two text inputs, so that once the background moves up and the original button disappears, the new button must appear in this micro interaction. So let's get started. Let's first add our new animated view right below this one. We have divided its height by 3, so that this screen is divided into 3 equal parts. But what we want is our text inputs to be at absolute position. So let's add our text inputs. One is for email, and one is for password. We can see this slightly because it's in black color. We can see it appearing here. So let's add some styles for this text input. Let's go to our styles section and add some styles to it. So what we have added is basically height of 50, border radius of 25, border width of 5, margin horizontal of 20, some padding and some color. If we see now, we can see these buttons appearing, but we see these text inputs appearing. So but we also require a sign in button below, a new sign in button once the email and password is punched. So let's add one more animated view, which is basically our sign in button. And let's see, now we can see all our 3 things required once the background goes up, and these will appear for user, but we don't want them to be right in front of us at this moment. So let's give it a z index of -1, so that we don't see it right away. So now you can see it has gone behind, but we actually don't want to see it at all. So we should also add opacity. So now we don't see it anywhere. Next, let's add values instead of hard-coded z index and opacity. Let's actually pass animated values. So let's change our z index to this dot text input z index, and for opacity we have this dot text input opacity. We also have here a transform, so that when we slide in our new animated view, we do it with we replace translate y to this dot text input y. So next step, let's create these three values in our constructor. So let's first add in our constructor the text input z index from 0 to 1. When the button opacity is 0, we want the z index to be 1, and when the button is visible, we want the index to be -1. Next, let's add text input y such that in the interpolate, when the button opacity is 0, we want it to be seen. Else, we want the current position, we want it to be moved by 100. Lastly, we have our text input opacity, where when it's 0, we want it to be 1, and when it's 1, we want it to be 0. Let's save this. Look at reload our application. Let's click on sign in now. And as you see, it slides in smoothly. So let's retry it one more time. Let's try it. Super. So this is one of the most easiest micro interaction example, in which once the user clicks on a sign in for the login page, the form to enter email and password elegantly slides in with this simple interaction. Now that we are back from our demo, you can actually use this demo application and build upon this or look at this code. I'll be sharing the GitHub repository for the same. Next, let's look at the last part of our presentation, which is popular animation libraries for React Native. The first one is React Native Reanimated. React Native has a built-in animated API, and it is written from scratch by React Native Reanimated library to provide flexibility for gesture-based interaction, along with creating animation in the apps. The React Native API has some limitation in terms of gesture-based interaction, and this library tends to solve it. It has full native support and performs animation directly on the native thread instead of JavaScript thread. That is an added advantage. The library is actively maintained by developers at by the core contributors and developers at even Expo. So it's a pretty robust library to be used. Let's move to the next one. Next, we have a React Native animatable. It's one of the most popular animation gesture library with 8.7 thousand stars on GitHub at the time of making this talk. It has vast set of properties for declarative usage for animation, looping, generic transitions, and a lot more. 60 plus built-in animation. So it's pretty much plug and play with this library. The next one is React Native Shared Element, which provides some set of native building blocks for performing shared element transition. This library tend to solve a set of specific problem through its native implementation approach. Few of those are CPU and GPU interface, no flickering, scroll view clipping, shadow transition, crossfade transition, and a lot more. It also provides a shared element stack navigator, which is similar to stack navigator, which you can use to wrap each route when you are building your animations, your transitions. Let's move to the next one. Another one which is a very powerful library is React Spring, because it's a physics based animation, and a lot of time we do require some physics based animations to be part of our micro interaction. It's one example is if you are showing a download button, and if the user moves the device, we can actually show, the download wave animation is also moving along with it, and it gives a more realistic feel to the application. It has APIs available in the form of plug and play React hooks, and most of these hooks are can be implemented very easily in a 3-step process. Cool. So now we are end of our agenda. We have completed all 4 sections of our talk. But I thought I'll also delight my audience today by adding one additional part to my talk, which is quick tips of which you can use, which I have been following for some time. So the final one last thing in this talk is quick tips on micro interactions. So I have split it up into 5 parts, which is purpose, structure, simplicity, life, and retirement, experiment, and test. So what is a purpose? The first thing first, micro interactions must have a purpose. They are supposed to encourage user to interact with certain part of your application. So make sure they are functional and they have a purpose to work on. The second is follow the structure. When it comes to micro interaction, we know the 4-part process of trigger, rule, feedback, loops, and mode. Follow the process. It will make a great interaction for your application. Keep it simple. Simplicity is the key. There's a reason micro interaction is called micro interaction for a reason. They must be short and sweet. Micro interaction are there to improve your design, make things look clean and feel clean. So keep them simple. Don't add like too many animations and too many gestures, which makes the user actually irritated. So just keep it simple and clean. Think about life and retirement of your micro interaction. So micro interaction must have a feel of natural thing to the user. They most of the time they shouldn't even notice it, and if they are noticing it, it is because of a pleasant experience which they carry while using the application, not because they are fed up of the application. So make sure you build an interaction which is kind of timeless and stays with your application for a long time. And lastly, experiment and test. Anything which goes out in production in public it must be tested and improved upon. So there should be some ways to gather feedback, analytics, experiment, fail fast, move to a new micro interaction, or improve the existing one. So that's about the 5 quick tips without taking any more time. I would say that's a wrap, folks. Thank you so much for attending my talk, and thank you so much for Geekle and conference organizer for organizing this conference. Last 1 year has been tough for all of us, but I think our energy in building, creating such conferences and connecting with each other virtually, and especially all the audience attending the conference. I'm really thankful of you. Do stay in touch over Twitter with Paul Akshat. Since we all are virtual, we don't get an opportunity to network how we used to do during live conferences. But dude, stay in touch via Twitter or via my website, akshapal.com. Happy to work with you on any problem you are stuck on. I'm always happy to solve interesting problems. And that's a wrap. Thank you so much, everyone.
All right, everyone. So, okay, great. We have questions already. So we'll be taking up all of those questions later in the Q&A round after the back-to-back conferences that we have lined up for you. So I present you now the next speaker, that is Syed. So by the time Syed is setting up his presentation, I will just tell you a little about what his bio is, and yeah, so for this blog about case studies and best practices, we have Syed. He is an enthusiastic learner and a JavaScript developer who loves working on React and React Native. I also Syed also like to give back to the community, and for that, he has given multiple tech talks and also contributed for the open source world, and he's still contributing, I guess. So okay, so I guess Syed will be taking up a little more time. Uh, until then, let's see where. So where are we from? So I saw Europe in the last comment, in the last previous link. So where are you people joining us from? I'm from India, joining you guys from Rajasthan. One guys.
Hello, Prakriti. Thank you for such a wonderful introduction.
Hi
I
Syed.
would say, yep. Hello.
So let's start your screen share,
Yeah.
and we'll just start the stage for you.
All right. So I'm just gonna share my screen.
Okay. Good luck.
Thank you. Can you guys see it? Um, all right. So I shall begin. So it's thank you for such a wonderful introduction, Prakriti. It was really good. I'm Syed. I'm a senior software engineer at Folio 3 from Pakistan. I mainly work on JavaScript and its related technologies, which I focus on React Native, and Node.js. In this talk, this presentation, we are going to discuss about the server-side rendering of React using Next.js. But before moving directly to Next.js, we'll first discuss about the server-side rendering itself. What are the types of server-side rendering? We'll do a small performance analysis of server-side rendering, and then we'll move towards the Next.js. First introduction and some pre-rendering types of Next.js, and then we'll finally move towards the code demo. So let's start with the server-side rendering. That what is actually server-side rendering? So server-side rendering is when the HTML is generated at the with the data at the end of the server. So in other words, when a user requests a website, server fetches the data, prepares the HTML, and then returns the prepared HTML to the user. So in this manner, user doesn't have to wait for the data to come when the website is already loaded. So let's see a timeline for the server-side rendering. We can see here that user opens a website, browser sends request to the server. In the meanwhile, user is waiting for the response. Like a user is seeing a white blank screen on a loader. Server will fetch the data from any resources, any database or other resource, and prepare the HTML with it, and then return it to the user. As soon as the HTML is returned to the browser starts downloading the JavaScript, and other assets. And when as soon as the JavaScript and the other assets are downloaded, browser executes the React in case of our Next.js, and and then the user is able to use the app. So this is just a simple timeline for the for server side rendering. And when it comes to the rendering, then we have two types of the rendering. One is the rendering, and the other is the dynamic rendering. Static rendering, as it suggests by the name, is it it plays with all the static data. In this rendering, data is always static, and HTML is generated just one time, and then it is used all the time. So the HTML is not generated at every request, but it's just generated at the build time. But when it comes to the dynamic rendering, in the dynamic rendering, the HTML generation is also dynamic, and that generation depends on the request. And then upon the request, server fetches the data based on the any parameter of the request, and with that data, server prepares the HTML, and then that returns to the user. So let's understand it again with the flow diagram. We can see here that user requests to the server has everything stated: HTML, CSS, JavaScript, and CSS, and server then simply returns the static HTML to the user. But in the case of dynamic server-side rendering, server user request to the server then on the basis of those requests, server then requests to the database or any other resource, and then as soon as the data is arrived to the server then prepares the HTML for that data, and then sends back the dynamically generated HTML to the user. But notice that this part when the server is requesting the data from the database, that this can take some time. So we'll come to the metrics in the performance analysis for coming. So before moving towards the analysis, first we I would like to share what metrics we would be discussing in the performance analysis. The first is the time to first byte. Time to first byte for any web app is the time when the user first hits the app, hits any URL, and the first byte that is received to the user. So that is the time to first byte. And the first contentful paint is refers to the visibility of the content to the user, when it's the first time any content is visible to the user. And that content does not include any images or some other stuff, but any meaningful content like text or article bodies and the other stuff. And the third metric is time to interact. The time to interactive is we can say the time when user is able to interact with the website. So when we work with the client side rendering, when we deal with the client side rendering, we see that after the website is loaded, we see a loader moving around, and we are still not able to interact with the website even the website is loaded. So this is the time to interact, that how when user is able to interact with the website. So when it comes to the server-side rendering, the first contentful paint for the server-side rendering is relatively fast than the client-side rendering, because the HTML comes prefetched with the data. The data is already there with the HTML, and also the time to interact for the server-side rendering is pretty fast as compared to client-side rendering, because in terms of server-side rendering, there is no JavaScript API calls and other execution that will block the user from interacting with the website. But as I discussed earlier, that since the data fetching happens at the server side, so the time to first byte can be longer for server side rendering. So you can simply say that the load time for the server side rendering can be longer, because fetches some data and then prepares the HTML with it. So this is one comparison for the server-side rendering and client-side rendering, which I picked from an article from Google. We can see here that when in the case of server-side rendering, as soon as the user request any page, we get the first contentful paint, and right after that just after a few seconds, in fact milliseconds, we user is able to interact with the website. TTI has completed. But in the case of client-side rendering, we see that the user has requested the HTML. In the client-side rendering, we get an empty HTML or HTML with with static data. We then The client then downloads the JS and then start executing the JS and making the API calls. And in that time, the user is completely blocked and cannot interact with the website. So this is one of the major difference between the client side rendering and the server side rendering. But another advantage of using server side rendering is the SEO, search engine optimization. Why it is Basically, the server side rendering is very much recommended for a better SEO. Why? Because it is very easy for crawlers to crawl the website that are rendered at the server side. And why is that? Because as soon as the website is loaded, a crawler can crawl a website. If you think from the perspective of the crawler, as soon as the crawler goes to crawl the website, the crawler waits first it waits for the website to load, and then it wants to crawl it as soon as the website is loaded on the window.onload event. So this favors the point of server side rendering, that as soon as the site is loaded, the crawler can start crawling the websites. But in the case of client side rendering, crawler has to wait even after the website is loaded. So it can be a bit difficult for crawler to crawl websites that are rendered client side. So this is one of the advantages as well for using server side rendering for better SEO. One of the reason for starting with the Next.js in our company was this, that we wanted our website to be better SEO search engine optimized. So coming back to the problem that we discussed earlier about the slow TTFV, slow time to first byte, or you can say the a longer load time for the website. uh, we know that it happens because server has to fetch data and prepare the HTML with that data. And server fetches the data from most of the time from the DB, and then what we can do to improve it, we can add caches, DB caches like Redis in between the server and the DB, which can somehow improve the time for data fetching time for the server, and will eventually improve our load time. And the other things that we can use and decide by ourselves, that where we should use static rendering and where we should use dynamic rendering. Because if we decide properly that if our work can be done with the static rendering, there's no need of use dynamic rendering, and static rendering is very much faster than the dynamic rendering. So that was some introduction for the server side rendering. Now coming to the Next.js, I hope you guys understood the basic point of server side rendering. Now coming to the Next.js, Next.js is the framework for React.js React.js rendering of server side. At the backend, Next.js uses Node.js, and for the UI, Next.js uses React. Next.js itself is a very powerful framework. It obviously have all the features that are needed by the server side, that pre-rendering, and generating the HTML at the server side, and a better performance for the SEO. And again, Next.js supports all both the two types of rendering, the static rendering and the dynamic rendering. So, but the Next.js calls the static rendering as static generation, and the server side rendering as the dynamic rendering as the server side rendering. But I'm going to again repeat what was the static generation. The static generation was when the HTML was generated at build time with the static data, and then it is not generated on every request. But for the server side rendering or dynamic rendering, HTML is generated on every request. So let's see the pre-rendering. It's pretty simple. It's pre-render HTML is displayed here with the data. JavaScript loads here. The React hooks up, and then we are able to navigate and all the interact with the website. But in the case of normal plain React app, JavaScript first needs to be downloaded. App is not rendered yet. The app is HTML is empty, and as soon as the JavaScript hooks up, then the React components hooks up to the app, and now app is interactive as well. So and the static generation or static rendering, Next.js has further divided the static rendering into two parts. One is the static generation, that is the default one that we discussed both the times, and the other is the static generation with data. This is the static generation with data, and the data is dynamic. But since it is the static generation, this rendering also happens at the build time, but the data we have here is dynamic. So this is one small difference between the static generation and static generation with data. And I must tell you that the static generation, just the static generation is recommended by Next.js, and it is the default way of rendering. So even if you're not using any out of the box server side function for Next.js, then Next.js will all use the static generation for the rendering of the component. So let's move forward. Let's see the static generation without data. In this case, at the build time, HTML pages are generated. There is no need to fetch any external data. We are using all the static data with the HTML, so it's pretty simple. But when we see the static generation with data, what happens here is that at the build time, note that at the build time, not at the request time. At the build time, Next.js fetches some external data based on any parameters, and then prepares the HTML with that data. But again, I'm going to emphasize that this happens at the build time, not at the request time. And the third time, that is the dynamic rendering, we already discussed it. That servers at every request, the server is going to fetch some data and prepare the HTML. There are some out of the box functions that are provided by Next.js for the server side rendering. One is this get server side props. This is the function where all the server side stuff would be done, and this function only works at the server side. We get the access of request in this function, and using that request we can fetch any relevant data, and then pass that data to the HTML. One thing I missed there, for which I would like to go back, is these two functions which I missed to discuss about: get static props and get static paths. Get static props is similar to the get server side rendering function that we just discussed, but this function only runs at the build time, and this function gets server side props always runs on at the request time. There is one third function that is get static paths, and this is for building for the static paths at the build time. We'll come to that later in the code demo. So as we were discussing the server side rendering, at the server side rendering, user as whenever user requests a page, HTML is generated every time the user is requesting the page. From the flow diagram, we can understand that user requests a page, Next.js fetches some data, prepares the HTML, and then returns the HTML to the page. And this cycles happen every time user is requesting the page. Unlike the static generation with data, that the this cycle only happened at the build time, and this generated HTML was reused again and again for the same request. So now when we want to use Next.js, what are the prerequisites for it? For the prerequisites for Next.js is simple: Node.js, the latest version of Node.js, and any comfortable editor that you like. For how to bootstrap Next.js app, if you have the latest version of Node, then you would probably have npx by default, and we have a command line tool for the Next.js that is called create next app. Using this now command line tool, we can simply bootstrap a Next.js app. Uh, this From the npx to create next app. This is the command line for creating the app, and this is the name for the app that we want to give. There are other options as well with this create next step command line tool. This tool is itself a very powerful tool. There are multiple templates online uh, which you can use to bootstrap the app. Like you can use the TypeScript template and other template. Uh, this here what we are saying will initiate with bootstrap a very basic next step, but if you want to use any template, then you can also use the template with this command, and the app that will be bootstrap will be much more better than the basic version of it. So when it comes to the front end, or for a web app, one of the major thing is the routing. That whenever we start with the web app, first we focus that how we are going to uh, navigate between the pages, what would be the architecture of the pages, and then how what would be the flow of the app, the routing of the app. So the Next.js routing is pretty simple. It's very similar to the PHP, where there is one directory, and that's called pages at the root of the project. In and whatever is there in that page, in the folder, in the directory of pages, will be resolved as a route at Next.js. So for example, if we have a page here, if in the pages folder, in the pages directory at the root, we have a folder named for posts, and and a file name first post.js. Then the route for this page will be posts and the first post, and simply the first post. So it's very simpler similar to PHP. Whatever you will add inside the pages directory will be resolved to the route, and the route for the app will be resolved with the index.js, like pages/index.js file that will resolve to the root route of the web app. Now, coming to the routing, the navigation, how we discussed that how the routes will be made. Now how now there comes a question that how we are going to navigate between the pages. Well, there are we can navigate between the pages using the anchor tag itself as well, but there is another thing that Next.js provide out of the box, that is the link component, and it's very simple to use, and it just wrapping an anchor tag with the link component, we can achieve the client side navigation of our application. So whenever we can see this here in the example. This is the example for the page for the route. This is the pages for directory in our root, at our root of the project. The posts the post file or the post folder, and then the first post.js. So this will be the route of our first post.js file, that is the slash post slash first post, and the root of the app will be at the index.js file. Whatever we want to render at the root of the website, we have to put that in the index.js. And now discussing about the routing, the navigating between the pages, we have simply the anchor tag, and we have wrapped the anchor tag with the link tag, with link component. Notice that the href is not inside the anchor tag, but it is with the link component. So this is one of the uh, needed thing for this link component in order to achieve the client side rendering. Now coming towards the assets, metadata, and css. So discussing about the assets, Next.js can serve static assets inside a public folder, that too will be at the root level, and whatever will be inside that public folder can be accessed directly in the app, rather than providing a complete path for that asset. So this makes a very easy to use, accessing assets very easy. And I'll show that. I will also show that in the code example as well. And now coming to the metadata, let's see it through the code. Um, so I have created this project. This is the very simple project that I have created from the next year. It's uh, learning part on next year's official documentation. So this layout is common on every page, and every page is wrapped in this particular layout. So and for in order to add metadata to any web page in Next.js, uh, we have to use a tag that is called head, or a component that is called head. Now the question comes here, that why we need to use the head tag when we can add directly use the link and other metadata tags. Well, the reason is that the HTMLs are generated pre-generated at the server side. So some things that cannot be so if we'll use these metadata tags outside of the head, then that these will not work. And if you if in order to work with the metadata, we'll have to put that metadata inside the head tag, and simply whatever in that will be in the head tag will be will be rendered for the metadata. And if it can be overridden, like if you want to have a different like if you want to have a different title for different pages, then you can simply use the head on other pages as well. So it's not necessary to use the head at the root level, you can use the head at other pages as well. And now coming back to the presentation. So the third thing is the CSS. Next.js provides a very good support for the CSS. Like you can use the styled components, styled that is one approach, and then the other approach is the styled JSX, or you can simply use the simple CSS. But and the fourth one is that the modular CSS approach, which I've also used in my demo, my example. We can see here that I've created a file called layout.module.css. In this file, we have just a few classes, and we can simply import this file in our component like this, and then use the classes as a just like we are using a JSON object. One benefit of using the modular CSS is that whenever we'll let me show you the whenever we'll repeat the name of any class name, then it will not create any issue for us. Why? Um, why? Because when we use the modular approach for the CSS, the class names are always generated. Although we are using a simple class name, that is container, but when it comes to the rendering, the class names are always unique for the module CSS. You can see here that I use the class container, uh, like this. and I've used this container at the div and this div, and at the end you can see that this container this container class is rendered as a as a unique class name. So now we can use the say we can summarize that this we can use same name at other css files as well. But there is one limitation of one that is that in order to kick it off and work with this modular approach of css, we have to make the css file with the name of dot module dot css. So it is necessary to add dot module dot with in a file to in order for Next.js to understand that okay, I have to uh, use this css in this manner. And talking about the CSS, let me show you the image part as well. So I have put this image, my file image in this public directory in a folder of images, and then the file name. So how am I accessing this image? It's pretty simple. You can see that I have not provided a complete path to the public folder, but I have simply just added uh, the path that is inside the public folder, and Next.js will eventually uh, get the image source and render it. One more thing about the images that the yep. So Next.js suppose automatic resize and optimization of the image, uh, and so this is one of the things that comes out of the box for the Next.js, and it is complete and it is provided by default. You don't have to do anything separately for this feature. And one more thing, that the images are only loaded when they enter the viewport of the website. If for someone who doesn't know what is a viewport, then viewport is the when it comes visible to the screen. That's what it's mean. So notice that this is just for the example I wrote here that the complete path for the image, if had it not been the Next.js static path public folder, I had to give the feature that Next.js provide to um, access the asset. I would have to provide this complete path. It looks dirty when we compare it to this path. So yeah, and now coming to the third thing, that is the pre-rendering and data fetching. So this is major demo or stuff that we are going to cover now. That's just the pre-rendering of the Next.js. Uh, Let me first give the demo for the app, that what the app is doing. So simply at the root of the app, we are rendering two list items, and these list items take us to the blog itself. Yep. So you can see here that upon clicking that list item, I'm able to see a blog. Sorry, and then again this second list item, I will be able to see the blog. So on the at the root of the web app, we are rendering these two list items. So let's see how we are rendering these two list items. So coming to the pages, as I mentioned before, that the root file for the our web app would be pages, um, and for and slash index.js. So in this index.js, you can see that this is one the function that is called get static props. This function only runs at the server side, and again this function runs at the build time, not at the request time, but at the build time. But in the development mode, it always it runs at the request time, so that since we are developing it right now, but at the in the production mode, it only runs at the build time. One more thing, this function that is only allowed in the pages folder. Uh, if you use this function in any other page, like any other folder, and then this function will not work. Next.js only knows that to render server-side rendering, that is that whatever is inside the pages function. So let's see. Uh, So yeah, you can see that this log that I have added in this function only ran at the server side, and this log that I have mentioned here in the component ran at both places, the server side and at the client side. How we can see that at the terminal from where we have run our application, we can only see the log of I'm running at server, and at the console at the client we can see that I'm running at the client. Um, why we are seeing this at the server side? Because Next.js prepares the HTML at the server side for pre-rendering and then sends it to the client side. So this runs always once at the server side as well. um, so yeah, so what is happening is that at the server side we are fetching the data for the posts. I assume that this is some API call, and then we are fetching the data from some API or from data or on any database, and then we, after fetching that data, we return that data to the props. And then what happens? The question arises that what happens then? After we return this data in the props, then this component that is inside the pages will get the data in its props. So what happens is that first this function runs, this fetches the data, and it returns the data to the props, and when as soon as this component starts hooking up, it receives the data, and we can then simply return render that data. So that's how the server side rendering works. And similarly, the same approach we can use the function of get server side props, but the difference would be that function would run at every request, and not and this function would always run at the build time. But since we are working in the development environment, we are seeing this log here. So in the development environment, this function runs every time. um, One thing that I would ask myself when I'm working with any web application, that how we are going to use the dynamic routes. At any route that like if we have the product detail, uh, or say detail and any specific ID, then I want that for every specific ID I see every different page. So how am I going to handle the dynamic routing? Because we all know that we haven't discussed the dynamic routing yet. And but why we haven't discussed it? Because we are just going to discuss it now. Like you can say like this is the route that we want to make, and how we are going to make it. We're simply going to add, this is the out of the box approach that is provided by Next.js. That is inside the post folder I have created a file id.js, but it's not a simple id.js, but you can see that this id is inside the square braces. The reason of putting this id inside the square braces is that whenever we want to uh, fetch any parameter of the request, and that parameter, just suppose that I want to fetch this parameter of the request for server to fetch the data from the DB. So I want some variable at least something to access this variable, at least some name to access this variable. So what name we would in this example, like we have post. So post slash our ID, and since we need anything, any variable, any name to access this variable, that name would be ID. We have that name would come inside the square braces, so we can write anything here, whatever we would like to have. And how we are going to access it? In the function that we used earlier here, get set props, we are again using this function because we are using working with the static data, but we are building that data at the build time, generating the HTML at the build time. So in this function, we get we receive a property in its argument called params. Params are basically the route params of the route, and in this param we can access this variable with this ID with a variable ID. Why we can access this variable with the ID? Because we have named the ID, the file with the square basis ID in it. If I'll change suppose and say just EEC, and then I will have to access this with in this way. So this is how we are going to access the dynamic. We are going to make the dynamic routes and access the data from the request. Um, but one more thing that there is another function that is called get static paths. Why we are using this function? And notice that I'm only fetching the IDs and returning the ID array from this function. The reason of using that is that since we are using the dynamic rendering and that also at the build time. So Next.js at the runtime needs to know that what path Next.js should expect. So in order to tell for this static data, so in order to tell the Next.js that you should expect these paths for this file inside these data, for these data we will simply fetch the IDs and then return it to the and then simply return it from this function, and that's how Next.js would know that okay, we I have some dynamic page rendering at the build time, and in order to you reuse every part, every page is HTML. We can tell that okay, these are the paths. So one of the main another reason for providing these paths is for Next.js is to reuse the pages. Uh, this page is not rendered at the runtime, but it was rendered at the build time, and now no, and similarly this page is not rendered at is not recreated at the request time, but it was created back at the build time, and Next.js is not simply just reusing that page. So in order to Next.js to reuse that dynamic page that was built at the build time, it is necessary to provide the paths return that 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 the Next.js should expect. Um, that's just simple example for the for how the server side rendering would work. But that's just not the end of the Next.js features. One more thing that I would like to add that um, I didn't mention, but I would like to go on with that. We can also make APIs using Next.js, and they are so simple to make that it feels like just like a piece of cake. And but it is necessary to make an API. It is necessary to to put the API our API in the folder of API, so that Next.js would know that okay, this I should treat these files as the API files, not as the front end files. So it's pretty simple to access the API. So to make any API in the Next.js, so you can see here that in the pages folder I have created a folder named API, and that folder I have created a path. I'm using the word path because eventually in the language of Next.js, this file is the path. I've created a path called hello.js, and let's see if it's working or not. So we can see here that I created just simply the path for the API is this path, and I can see the response that I have written from here in my screen. So this is another feature of Next.js. Apart from this the server side rendering, we can also make APIs using Next.js. One more thing that's not mentioned here, we can also overwrite the Node.js part of the Next.js if we need anything like that. Although we wouldn't need something like that, but we can override, and for that we will have to use the server.js file, which I have not mentioned, and so it's and it would also be something advanced for our for our current discussion. So that's all for the Next.js introductory session. Um, I hope you all liked it, and I'll be responding to the questions if you have any. And I hope that you guys will be using the Next.js uh, in your application, in your development, future development as well. Thank you.
Uh, Thank you so much, Syed. It was a great insight on Next.js and all the related, the color plate that you created and a little bit of here and there edits that you've made. Really
Thank you.
liked it. Thank you so much, Syed. All the questions related to Syed's talk, we'll be addressing it later on uh, in the Q&A session. Until then, please hold back your questions and answers. Uh, and let's talk about the next uh, discussion that we are going to have. Okay. So, next discussion that we have on case studies and best practices is from Matias. Matias is a front-end developer from Argentina, currently working as uh, the head of front-end at the Valtech. He says that he's a foodie and he's a father of two, and he's the best bugs resolver ever. So let's call him up on the stage and let's get on with his uh, discussion.
Have you had the feeling that your bundle is getting out of control? Someone told you you had to work on your site performance and don't know where to start or what to do? Well, I had the same feeling some time ago. Last year in a big project, they asked us, hey, what about performance? I'm Matias Arabolaza, head of frontend at Baltec, and today we'll take a deep dive on how Lighthouse and web performance really work and how can it help you make your website lightning fast. Let's get into it. So this is the agenda for today. First, where to start, right? We will check the fundamental of Lighthouse, how to understand it, concept behind it, audit, etc. We'll go through by some metrics, why numbers are important, why speed is important too. Then the most common bad performance reasons, and finally, what we can do to fix them and possible solutions. But where to start, right? Well, it sounds like a basic question, but what is Lighthouse? Basically, Lighthouse is an open source tool for improving quality of web pages. Is there any alternative to Lighthouse or tool to measure your performance? Yes. Some of them are Creepy, Shitty Metrics, PageSpeed Insights, Yellow Lab Tools, and others. If you ask about PageSpeed Insights, this is slightly different from Lighthouse. For instance, PageSpeed is only evaluating performance and not accessibility, CEO, and others. So you can use Lighthouse to audit performance, accessibility, progressive web apps, best practices, CEO, and more. In all of these audits, you will have an overall score, areas to improve, and opportunities. But today, we will talk about performance only. And for that, we have to know how to understand Lighthouse. I think to understand Lighthouse, we have to know first the concept behind it. These concepts are used in several other tools, like the previously mentioned, right? We have 6 concepts or audits that Lighthouse is going to check. Some of them are more important than others or have more weight in the score. The first one is first contentful paint. This metric measures how long it takes the browser to render the first piece of DOM content after user navigates to your page. And what is the first piece of DOM? Well, it can be text, only text, images, non-blank and canvas element, and SVG. Anything inside an iframe isn't included. Before continue, sorry, if you wonder how to improve this, let me tell you something. Unless you have a specific reason for focusing on a particular metric, it's usually better to focus on improving your overall performance score and not only one specific reason. Sometimes you will notice or you will have the experience that you want to improve a specific reason and then you can decrease other scores from others audits, right? So at the first gap or first level, it's better to improve the overall score. Next one is speed index. These metrics measure how quickly content is visually displayed during page load. It is the average time at which visible parts of the page are displayed, expressed in milliseconds, and depending on the size of the viewport, the lower the score, the better. The calculations calculates what percent of the page is visually complete at every 100 millisecond interval until the page is visually complete. Speed index only takes into account the above default part of the page. This is directly visible by the user, right? As a consequence, this metric is highly dependent on the viewport size. Largest contentful pane reports the render time of the largest image or text block visible within the viewport. What is a good LCP score? Well, to provide a good user experience, I should strive to have largest contentful pane of 2.5 seconds or less. I'm sorry. But, well, what elements are considered for LCP? Well, can be image elements inside an SVG elements, video elements, elements with background image load by the URL function, block level elements containing text node, or other inline level text element children. Now, yes, the next one is time to interactive. These metrics measure how long it takes a page to become fully interactive. So when a page is considered fully interactive, well, it can be when the page displays useful content, which is measured by the first contentful pane. Be careful here because you are having a metric. This is time to interactive that is depending or indirectly depending on other audit, right? Is in this case is first contentful pane. So then when event handles are registered for most visible page elements, and then when the page responds to user interaction within 50 milliseconds. Next one is total blocking time. This metric measures the total amount of time between first contentful pane and time to interactive. Again, be careful here because we have not only one, if not two metrics that are impacting in this audit that is total blocking time, right? So the main thread is considered a block anytime there is a long task. A task that runs on the main thread for more than 50 milliseconds. We say that the main thread is blocked because the browser cannot interrupt a task that is in progress, right? So in the event that the user does interact with the page in the middle of a long task, the browser must wait for the task to finish before it can respond. If the task is long enough, anything above 50 milliseconds, it's likely that the user will notice that the delay and perceive the page as sluggish or chunky. The last one is cumulative layout shift. These metrics measure the sum of all individual layout shift score for every unexpected layout shift that occurs during the entire lifespan of the page. So a layout shift occurs anytime a visual element changes its position from one render frame to the next one. That layout shift only happens when existing elements change their start position. So if a new element is added to the DOM or an existing element changes size, it doesn't count as a layout shift as long as the change doesn't cause other visual elements to change the start position, right? As you can see in the metrics, most important ones are total login time and largest contentful pane. Then we have time to interactive and first contentful pane and speed index with 50% of the score. And lastly, but not less important, is cumulative layout share. Right? So a super useful tool that Lighthouse provides us is the scoring calculator. With this tool, you can put your numbers there and see how the score is affected by this one. And you can play with the values to check what is the number that you need to get a green or just to improve some metrics. But this is a very useful tool to check how is your score doing and what you need to get successfully, right? Continue with the metrics. Metrics have color codes, right? As you can see, 0 to 49 is a red. It's a poor, bad performance reason, no, bad performance. 50 to 89 is orange, needs improvements, and green is 90 to 100. But why numbers are so important, right? So we have some metrics and numbers here. So we can see that, for example, 100 milliseconds is about the limit for having the user feel that the system is reacting instantaneously. Just only 100 milliseconds. Yeah, that's correct. That's very snappy, super fast. So in 100 millisecond delay, inside loading speed can cause a 7% drop in sales. That's a lot, and in several cases, a lot of money, right? 47% expect a page to load in 2 seconds or less. And 40% of the users will abandon a web page if it takes more than 3 seconds to load. So yeah, some of you for sure are you going to abandon a page that is taking more than 3 seconds, right? So don't panic. In this section, we'll take a look at the main bad performance reasons and then what we can do to fix them. So first one is big bundles. Big bundles can be the main reason of your performance issues. JavaScript is parse, compile, and execute in the main thread of the browser, which means the users have to wait for all of this before they can interact with the website. This might bring several problems. Super big network payloads, especially consider slow connection with some mobile devices. Your page will not be interactive until it loads. Parse time. Modern JS engines are fast, but the more code you load, the more the browser must parse through, right? Execution time. The more that you want to execute, the more code that you want to execute, the longer it will take. Again, your page won't be interactive until much of this completes. And lastly, memory consumption. Everything that take up a space, so the code itself, runtime variables, DOM elements, etc. So the warning remove unused CSS or remove unused JavaScript appears when Lighthouse has found too many CSS or JS code on a page that are not being used at the moment. Because of this unused code, the page loads slower than necessary. Why? Basically because there is unnecessary network traffic, because the files or bundles are larger than necessary. Therefore, it takes longer to parse, compile, and evaluate the scripts before the browser can proceed with all the other work that is needed for rendering the page, right? As you can see, always large network payloads are highly correlated with long load times. In this case, you can see the metrics remove and use JavaScript affecting in a critical way the, the loading of the page, right? For example, suppose that you want to use Bootstrap button on your page. So to use the button component, you need to add a link to Bootstrap style sheet in your HTML like this. So this style sheet doesn't just include the code for the button component, right? It contains the CSS for all the Bootstrap components. But you are not using any of the other Bootstrap components. So your page is downloading a bunch of CSS that it doesn't need. Having a bad image strategy optimization can be the root of important problems too. So this will increase the network payload for sure, and it can increase the time to interactive. Moreover, image take up more than half of the page size. Then large unoptimized images will cause visitor to bounce, and in time, Google will notice as well, and it will affect your CEO for sure. This is not going to affect your bundle size, but it's going to increase your payload network. So what is the payload network? Well, basically, is that everything that the user has to download to have the page interactive. This can be JavaScript and CSS files, images, videos, etc. So based on the HTTP archive data, the median network payload is between 1.7 and 1.9 megabytes. So Lighthouse flags page whose total network requests exceed the 5 megabytes. 5,000 kilobytes, right? In some moments, we will check best way to improve this problem. So render blocking resources are static files such as fonts, HTML, CSS, and JavaScript files that are vital to the process of rendering a web page. So when the browser encounters a render blocking resource, it stops downloading the rest of the resource until these critical files are processed. So in the meantime, the entire rendering process is put on hold. On the other hand, non-render blocking resources don't postpone the rendering of the page. So the browser can safely download them in the background after the initial page render. So if you reduce the numbers of render blocking resources, you can shorten the critical rendering path and reduce page load time, right? Therefore, improving the user experience and search engine optimization. But I mentioned something before. So what is the critical rendering path? It is the minimum steps that the browser has to take from the moment it receives the first byte of the HTML document to the moment that it renders pixels on the screen for the first time. So essentially, it's what the browser has to do to process our critical resource into something that our user can enjoy. So which URL get flagged as render blocking resource? So it can be that a script tag that is in the head of the document, for example, a script tag that doesn't have a defer attribute, and a script that doesn't have an async attribute. For the style sheets, we have the tags that doesn't have the disabled attribute. So when this attribute is present, the browser doesn't download the style sheet. And we have tags that doesn't have a media attribute that match the user devices. So we can have like the attribute media set to print. So this attribute is not going to match our device if we have a laptop or we have a mobile phone, right? So this is only just for printing, but the browser is not going to download that style sheet. Well, not too much to say here, right? We all know that notable folders can get out of control very easily, right? So this third-party code generally refers to scripts embedded in your website that are not authored by you and served from third-party servers. Some examples, some examples can be social sharing buttons, video player, carousels, analytics libraries, helper libraries like date formatting, animation, functional libraries, and more. Whatever you can think about it, it can be a third-party library. So any significant amount of JavaScript can slow down your performance, but the main problem is that the third-party JavaScript code is usually outside your control and it can bring additional issues, right? So for instance, network issues. Setting up connections takes time, and sending too many requests to multiple servers causes slowdowns and latency problems. Extra parts compile and execute. As this is JS code, the browser has to parse, compile, and execute, and that could increase several audits. Another example is rendering. The way that third-party JavaScript is loaded matters a lot. So if this is done synchronously in the critical rendering path, it delays parsing the rest of the document. And in the previous slide, we talked about blocking render results. So, well, this could be a problem. If a third-party library is being loaded synchronously, it's going to block the rendering process. So, what we can do to solve these issues, right? Well, let's go through by puzzle and super easy solutions that we can implement in all projects. First, you have to know what you have under the hood, right? The bundles, the libraries, the code that is living in your application. There is no best way to know this as the bundle analyzer or any tool that you want to use to check your bundle skeleton, right? We have several ways to know this, depending on the framework that you are using, React, Angular, Vue, or just vanilla JS. but we have a lot of options, right? In case of create React app applications, we have to use the source map explorer. We need another option, of course, but uh, so we have to install it with npm or yar, whatever you are using. Then add this, the script analyze to our package.json file, and lastly run npm run build and npm run analyze. So you will see a screen like this where you have all your bundles. We don't have colors, but well, it's a very easy way to know our bundles, the size, which orphan live maybe you are not using. So if you are using Webpack, you have to do something similar, but in this case, using the Webpack Bundle Analyzer plugin is a very good option. So similar as the previous example, you have to install it with npm or yarn, import this in your Webpack configuration, then include it as a plugin, and then when you run your normal build, it will create an interactive visualization of your bundles. As you can see, this option can be more intuitive since we have colors and another structure. It's a bit nicer, and you can zoom in and zoom out the bundles that you are using. So pretty basic and simple, but sometimes we forgot to set our project for production. Many libraries will key off the mode variable to determine what should be included in the library. For example, when the mode variable is not set to production, some libraries may add additional logging and testing to make debugging easier. However, with mode variables set to production, they might drop or add significant portion of code to optimize how things run for your actual user. So it will be much faster for sure. In case of Webpack, starting from version 4, it will minify your code by default in production mode. So if you are using an older version of Webpack, you will have to install and include, for example, the Tercer Webpack plugin into your Webpack configuration and run this by yourself. This is not happening create React app because that we only have to do is run yarn build that is going to build our project in production mode, right? So never is too much about compression, right? Right? When you go to production mode, Webpack is going to use Terser to minify your code. Minification does things like removing white space, removing comments, removing non-required semicolons, reducing hex code length, and stuff like that. So you can have a very simple code like this. This is normal JS code that you can write and read, of course. And if you minify that, it will look something like this. As you can see, the file remains perfectly valid code. You wouldn't want to try to read it or work with it, but it's not breaking any rules. The browser can read it and use just like it could be the original file. In this case, I assume that you can read it, right? I assume you don't want to read this one. Yeah. So compression is different. She find all repetitive string and replace them with pointers to the first instance of that string. This can be incredibly effective at reducing file size, especially with code, since it can be incredibly repetitive. On the web, shipping is done directly by your server. It's a matter of configuring the server to do it. So once that is done, shipping automatically happens. There is any, there isn't any ongoing work you have to do. Just the server compress the file and send it across the network like that. So then the browser receives the file and unzip it and unzip it before using it. If you want to go further, you have Broadly. So Broadly is also an algorithm compression. It is developed by Google and serves best for text compression. So as you can see, it's 14% smaller than GC for JavaScript, 21% smaller than GC for HTML, and then 70% smaller than GC for CSS. It is supported by all major browsers, as you can see. It's not supported by IE and Opera Mini, but then it's supported by all major browsers. Anyway, you can put a fallback for gzip if you want, so you can safely have an option if some browsers don't support this algorithm. So your application is growing every week. New features are being added, and its size constantly increase, right? So you want to provide great user experience, but downloading a lot of megabyte of the application uh, just to display a single screen doesn't seem right. Sure, I mean you can enable code minification and compression as we saw before, or caching mechanism, but eventually you will end up having the same problem. A large amount of data required to download to to initialize your application. Code splitting with React or any other JavaScript library of choice is the answer of this exact problem. When it's worth it to use code splitting? So in particular, when you have a large JavaScript application, sorry, when you need to initialize the app quickly without using too much processing power, example maybe for mobile devices, or when the application has multiple permission groups or sections visible only to specific users, as well as any maybe other case. When you need to show different content depending on the user. So to understand when we should use code splitting, we can also remember the audit that we saw before, time to interactive. So when it comes to single page application, the time to interactive is often too long for the users to patiently keeping waiting. So how can we do this in a Create React application? We can start using dynamic imports. So to start doing code splitting, we have to use this feature that is coming from Webpack, ready to use in our React application. Doing something like this, Webpack is smart enough to split this in a separate chunk. If you are using a React app, this is already configured for us, and we can start using it immediately. So it's also supported out of the box on modern frameworks like Next.js. But if we want to do the same with a React component, from release 16, we can use React Lazy. Basically, the React Lazy function lets you render a dynamic import as a regular component. This will automatically load the bundle containing the other component, in this case, when this component is first rendered. React Lazy takes a function that must call a dynamic import. So this must return a promise which resolves to a module with a default export containing a React component. But the lazy component should be rendered inside a suspense component, which allow us to show some fallback content, such as loading indicator or an entire component that you want. So the fallback props accepts, as I said before, any React element that you want to render while waiting for the component to load. You can place the suspense component anywhere above the lazy component. You can even wrap multiple lazy components with a single suspense component like this. As you can see here, you can wrap several components inside only one suspense component. So if the other module fails to load, for example, due to network failure, it will trigger an error. So you can handle this error to show a nice user experience and manage recovery with error boundaries. Once you have created your error boundary, you can use it anywhere above your lazy component to display an error state when there is a network error. Error boundaries are real components that catch JavaScript errors anywhere in their child component tree. Log those errors and display a fallback UI instead of the component tree that crashed entirely. Here's an example of how to set up route-based code splitting into your app using a React Router with React Lazy. So pretty nice strategy because what you would load in your homepage, the code that you need in the about page, right? In this case. So the user is not going, if you go to your homepage, the user is not going to see anything about the About page until it goes to that section, right? So this is a super smart strategy just to not load any page that you don't need in a page layer level, right? Sorry. So lazy load everything. Lazy loading is a strategy to identify resource as not blocking, not critical in this case, and load this only when needed, right? It's a way to shorten the length of the critical rendering path, as we saw before, which translates into reduced page load time. It can occur on different moments in the application, but it typically happens on some user interactions, such as scrolling and navigation. So you can lazy load JS and CSS files, images, videos, chunks, whatever you want. It can be lazy loaded. If the user never scroll to the point of the page that contains an image, then the user will never see that image. So it also never loads in the first place because it was never needed. So in that case, the browser is never going to download that asset. Based on the previous example, we can do something like this, or trigger this behavior whenever we want, when the user scrolls, clicks, or any actions. So as you can see here, Webpack is smart enough again to check that we have a flag that is using the state to show or hide this component, right? In case of images, we can use the native attribute loading, right? Setting this to lazy is going to lazy load the image automatically. Obviously, this is yet not supported by all the browsers. For example, Chrome, Opera, Edge, and some version of Firefox, it is supporting them, but for others, for example, IE, yes, IE, Safari, Opera Mini, and others, we have to implement some workaround or polify like this one, where we have to put, in this case, the URL in a data attribute. In this case, we can use data source. So with this, the browser is not going to load the image. And then when we need it, we can swap up the data source with the real source attribute of the image to trigger the downloading. So uh, for sure, maybe some examples of this, but basically is that you can trigger this on a click or maybe on a scroll event when the user reach that position in case of images, and then you can swap this attribute just to telling to the browser that you have to download this image in this case. This can be used by, I think, for videos too. So the browser must download and parse CSS files before it can show the page, which makes CSS a render blocking resource. If CSS files are big or network conditions are poor, requests for CSS files can be significant and can be increasingly increase the time it takes for a web page to render. So for that, we have the critical CSS technique. This is a technique that extracts the CSS for above the fold in order to render content to the user as fast as possible. But what is above the fold, right? So this is all the content a viewer sees on a page load before scrolling. There is no universal defined pixel height or what is considered above the fold content, since there is a myriad of devices and screen sizes. So inlining extracted styles in the head of the document eliminates the need to make an additional request for fetch this style. And the reminder of the CSS can be loaded asynchronously, as we saw before, using the lazy load strategy. There are numbers tools that can automatically determine the critical CSS for a page. This is good news because doing this manually will be a tedious process. So it will require an analysis of the entire DOM to determine the styles that are applied to each element in the viewport. And that will be a nightmare. So image optimization with Next.js format. So here, the opportunity section of your Lighthouse report will list all the images in other image formats, right? Showing potential savings gained by serving WebP version of those images. But what is a WebP format? Well, it was developed by Google, again, and is designed to create smaller or better looking image compared to JPG, PNG, or GIF image formats. In this case, WebP lossless images are 26% smaller in size compared to PNGs, and WebP lossy images are 25 to 34% smaller. Some of the most modern frameworks are using this format under the hood. For instance, Next.js with the new image component, I think starting from version 10, is using this under the hood. And Gatsby is doing the same, transforming images to WebP on build time. Otherwise, you have to do it manually, convert your image to WebP, and then using them in your project. Browser support, yeah, it's not universally for WebP, but it's pretty wide supported. Anyway, similar savings should be available in most major browsers in an alternative next-gen format. You will need to serve a fallback, maybe PNG or JPG image for other browser support in the case. So we talked about this in previous slides, right? How can a new JS and CSS can impact in your website performance? So shipping unused JavaScript or CSS is a common problem in web development, and sometimes it's not an easy problem to fix. Why? Because maybe you have third-party libraries, you have some code that you don't know that is there. So basically, how can you know if you have unused JS or CSS code, right? So Chrome has a coverage tab for this. Please see the image on the right. So you have to open the DevTools, go to Sources, press the Escape key, and if you don't have the coverage tab there, so you need to click the three dots on the left, right, and select the coverage tool in that case. Then you have to reload the page and record it. There you will see the percentage of unused JS and CSS code. As you can see, you can filter, and then for the type of the file, JS, CSS, and then you will see in red the amount of code that you are not using. So we went through several important topics here. We checked the fundamental of Lighthouse, concepts, grammars, and metrics. Then we went through by the most common bad performance reason, and finally, possible and easy solutions. I hope you can increase your website performance with all of these tips, and I hope you like it. So until next time, and thank you so much.
Amazing. So guys, it's an amazing discussion that has been going on since last 24 hours. So thank you so much for being with us. First of all, I'm amazed how cool it was, right? Like 24 hours of React.js content and more than like 50 speakers, hundreds of comments, and I mean, like, it's just amazing, right? So thank you so much one more time to all the attendees, because all we're doing it for you, for our amazing speakers, for our program committee, and of course, all our Geekle committee, right? So stay tuned for the next summit, of course. Um just a small announcement out here. Um, so scientists can say that every second developer initially wanted actually to become a game developer and not a grumpy CSS master, right? So this summer, our game development community is gathering amazing artists and developers from top studios to share their knowledge and skills with us. So save your spot today at an amazing early bid price to get your promotion to get your portion of essentials use cases for Unity developers, uh, networking with the global game dev community, insights from the team leads of Unisoft and Unisoft Studios, interesting and unique test cases from the famous game designers, and the link to the same is just on your screen. So scan this code up and yeah, go for it. Okay, so we have our Q&A round right now. I'm just gonna pull up Matias and Syed. Hello to you both.
Hello.
So how
Hello.
did the session go?
That was great.
Yeah, it was great.
Good.
So much fun.
Yep.
Okay, really. So I guess all the participants also had a lot of fun. Uh, so guys, please come up with your questions. All the participants out there, all the uh, questions holding back, please come up with your questions. Until then, I have a few questions for you guys. So the first question that we've got here for you is, what about the core web vitals? So there's a question that says, um, if you could just talk a
Mhm.
little about the core web vitals.
Yeah. Yeah, so worker vitals are a set of specific factors that Google is going to consider to make this kind of rank for page experience. So there are three important measures that Google is going to take into account. These are largest contentful paint, first input delay, and cumulative layout shift. So we don't have, for example, in Lighthouse, first input delay. I know that is something that they are working on. So I think in some next releases they are going to put this on the reports. But if you want to test this in a very fast way, you can use PageSpeed Insights right now. They are considering that in the reports.
Amazing. Right. Okay. So another question that we have from the community people, it says, how can we know if a third-party library is a good on performance? If it's performing good, if we should be using it,
Mm.
if we should not be using it.
Well, I mean, you have some options to check this, right? I mean, first of all, maybe you can check with the bundle analyzer if you have any issues on your site. So maybe there you can detect what is the third-party library that maybe is causing issues to your site. Another very cool option is our pages like bundlephobia.com. So this is a page where you can put the name of your library that you want to analyze and see what is the bundle size, the composition, the download time, etc. Very important to this, at the bottom of the site, you have like alternatives to that library. So maybe you want to change that library and maybe you don't want to Google it, they are
Right.
suggesting some alternatives.
Amazing. I mean, these kind of tools exist. It's pretty good to know
Hmm.
that.
Yeah.
Yeah. Okay, great. Uh, Sayed, would you like to add anything onto that, or, or have you been using this library or this application that Matias is talking about?
I'm sorry, but I missed it. I went away from my office work. I couldn't
Okay.
listen the Matias presentation. But I
So,
would like to
so
add one thing that like what we do before starting, like in when we work on React Native. So before using any third party library, we first check what I personally do as well. For you, we first check the issues on the GitHub, that what currently the issues
Mhm.
are there, and that whether this would be this library would be compatible with our version of React Native or not. And the
Right.
other thing is that if what how, is this library is still being maintained, are the maintainers active or not. So
Mhm.
just in case we come up with the out of the box problem, then whether it will be able to resolve, whether it will be resolved or not. Because it
Mhm.
may then happen that in some cases it is not, if we are not able to resolve it, then we can go with the option of forking that library and resolving it by our own,
Right.
and using it
Mhm.
using it for our use.
Right. So it's not just about how it's performing, it's also about if it does not have any, you know,
Mm.
issues that are not resolved and stuff like that.
Yep.
Right. Really
Yeah,
great
that is
point.
a very good
Great.
point.
Yeah. Great. Okay. So, Syed, these are some generic questions that we've got from the community. So, yeah. So, next question that we have is there a way to see a Webpack config in Create React app? If we can
Uh,
see that.
I don't think that the Create React app has the Webpack config by itself, but we can override it by using by installing it by our own. But at the backend, it manages by its own the Webpack
Okay.
config.
Okay. So, okay. I hope the community is happy with the answers. Like, cool. So the next question that is coming up is how can we split the code in Next.js?
It's since this Next.js is very similar to React. It's at the end of the day, it's using React. So we just have to keep a check that the code splitting, that whether we are the what are we doing at the server side and what are we doing at the client side. There is we can prepare a hook that we can that can tell us that okay, we are now at the client side or not, and now we are at the server side. But the code splitting would at the end would be done in the way that is done in like we do in the React.
Right. So Matias, would you like to add anything onto that, or you agree on with Matias? Saeed,
Yeah,
sorry.
yeah. I mean, super agree. I mean, in that case, I mean, you have Next doing this out of the box. So yeah, it's I mean, very simple to do that. So anything that you put in the page folder is going to be, I mean, Next is going to create a separate bundle for that. Obviously, you can go more in deep about splitting the code. I mean, it's the same as Said mentioned about React, but at least in Next it's a bit more easier because you have this out of the box, right?
Of course. Right. Cool. So amazing. So the next question that is coming up is how can we convert the images to WebP manually? Um, so
I don't think I have any experience of converting images manually.
okay.
Yeah, in that case, if you don't do this automatically, like using Next.js, the new component that they have implemented some months ago or some releases. I think it's
Mhm.
starting from version 10. They are using this, doing this automatically. You can, of course, use online converters. That is always an option, or some image editors. And then you have some plugins from Webpack to do this in a automatically way. I mean, you have to configure that for your project manually, but then you have
Okay.
the process automatically.
Cool. Right. Thanks for answering that. Uh, the next question that is coming up is, I think it's related with the Lighthouse. So, do you recommend any of the alternatives to Lighthouse, or you feel there are any downsides to Lighthouse?
Uh, well, I mean, maybe, I mean, PageSpeed Insight is a very good option. I mean, it's from Google too, but maybe it's a very good option because it's going to match the requirement for Web Core Vitals. But any tool that you can use to check performance issues is okay. I mean, if you have the details and you can have some guidance about what to tackle down about performance, that would be okay. But yeah, page speed inside is a good option too.
Okay. So, Matthias, how long has it been for with you been working with Lighthouse? Um, I mean, have you ever faced such a situation wherein uh, you just feel that it's a bad idea to use Lighthouse here or something like that?
I think not for the moment. I mean, I have been using Lighthouse for a while now, and I think I mean, they are doing great. They are doing like some upgrades on the time being. So yeah, I mean, I think I'm confident with Lighthouse in this case.
Okay, that's great.
Yeah.
Cool. So, okay, moving on to the next question we have. Oops. Okay. So it says, why CLS is the metric that has the lowest weight in the score?
So that one I think it's because it's not a performance metric itself, you know. I mean, it's more like pointing to a user experience. When you have like a community layout chef, you can see that your page is like having some jumps when it's loading, right? So
Mhm.
for that reason, I think about performance, maybe it has the lowest score with 5% only of the report. But then in core web vitals, it's going to take more importance to these metrics because the rank that Google is going to make is about user experience, right? So I don't know exactly the percentage, but for sure it's not going to be 5% only. So we have to be careful about that.
Okay, cool. Thank you so much for those answers. So,
You're welcome.
okay. So, what do you guys think about like the future of React? How is the front end is gonna develop in the upcoming years? How is it gonna uh, change or evolve the way we used to have HTML and now we have React, we have Angular, we have Vue. There's so many frameworks out there, right? So what do you think is how is React gonna turn up? How is front end gonna turn up?
Going to leave a space for Syed for that.
All right. So, well, I think that now that I was just recently reading the Redux documentation, and I could see that they have that when they introduced the slice part for the Redux, the reason for introducing that for the manageability of the code, and the old users of the React that who used to go around and then they see the old code of Redux, they were like that I don't know what I've done here. So so what I believe is that now, because React is very you have a lot of control on React when you compare it with Angular. So but with this control, you have to push yourself to manage it very with perfection, and manage the code with perfection. So I believe is that React is right now having its high time, and they should now start focusing on this code maintainability as well, because now
Hmm.
that they have also introduced the React hooks, and so
Yeah.
and which I believe that with the more power comes the great more responsibility.
Mhm.
So since the React hooks again are it's like component had when we were using the class based component, they were still some structure, but now that we have hooks and when we see the new programmers working, they just go out of the hand and before when with the maintainability and of the code. So I think that the future of this would be focusing on the maintenance of the code and the readability of the code.
Mm.
Right. What do you think, Matthias? How do you think it will change apart from maintainability and readability of the code?
I'm super agree on what I said about that. So I think, yeah, I mean, everything is important about. I mean, the community is doing a great job there. I mean, React in this case has, I think, the biggest community about in comparison for any framework. So I think that they are doing great with latest changes that they are adding to the library. So yeah, I think that's it.
Okay.
Mm.
Thank you so much, Matias and Syed, for connecting with us and sharing your so valued uh, insights on React, the Lighthouse, and Next.js. I mean, it's amazing how you have been, learning and developing all
Mm.
around it.
Thank you. Thank you
Okay.
for having me.
Thank
Thank
you
you
so
so much.
much. Yeah, it
Thank you.
was fun. Thank you. Bye bye.
Thank you.
Bye
Thank you.
bye.
Bye bye.
Okay, guys. So, just a small announcement. It's a giveaway announcement for you guys. So, our dear attendees, thank you so much for commenting on YouTube or the Pine and the talks that we've had, the interactions that we've had. We really value because all our speakers and the team worked really hard to make this event happen. And we're having a giveaway for our event among those who will be posting a tweet over Twitter and tagging our official geekle.us, geekle.us. Uh, that is at the rate Geekle official, and write about what you liked most about this event, the topic, the speaker, the presentation, the GIFs that we have all around. And there'll be like 5 lucky winners who will be getting 2 tickets free of cost for the next Geekle event. So yeah, that's a wrap for today's event. Hope you guys enjoyed. See you later, maybe next year. Bye guys.